did before, but in this case, using streams and lambdas and using constructs of Java 8. So our task is to read the file. The simple text file is exactly the same file that we used before, and we have to skip the header to read the data as lines, to tokenize and split the data, the lines into its string components, transform the strings into number, and just to do something on the data, what we want to do is to add them to an array or list of double, and then sum the data in each bag that we obtain. Finally, printing the results and write the result to a file. The strategy we use here is the same we used before. We are mostly doing all this stuff inside the main first, and then we rearrange and organize what we have done in classes. At present, we are doing these operations. One thing to notice, however, is that the use of lambdas force us to build just from the beginning some method of the class. We don't have any field here in this class, however, but we are doing two methods. I am not telling you what these methods do, but the name of the methods is more or less explicative, I will say, but I will explain to you later on when we will arrive in the main at that point. So we have the file name that we have to read. We say that we have header lines here. I put 3, but I guess it's 4, but yes, it's 4. Let's see later on what happens here. Maybe actually I'm not using it. So what I do, I get parameters for from file, not 0 but 1 now. I am instantiating a new object. So let's go directly to see what is getting parameters from files 1. I don't think it's different from before, and is a method that has 2 strings, which is the file name. Get parameters from file contains a field with a public field with the name of the file we are going to read, and then we have an array list of strings, and meaning that each element of the array contains a string, and we also with string is called text, and we allocate the space for this just at the beginning here when we declare it. We use the scanner class to read the file, and we use also the file class. We open a new file class, and with the file name, and we open a new scanner on the file class to read what is inside the file. We declare here that we use as delimiter any empty space. This is the regular expression for empty space or more than one empty space, where this is what the the class means, and we use a while cycle here to read the text from the file. What it does is the scanner class has a method xNext. It go and looks if there is the end of file or there is something else in the file. So it says, I scan a thing using this delimiter. So, and actually, if there is something, I scan an entire line. I can scan actually one character if I want, because scanner has also a method to assess single characters or single words. But here we use next line. We read the text line by line, and we add to the text array list. So each element of the array list is a line of text. That is get parameters from file 1. And let's go back to our main. Nothing we get is we get data here from get parameters from file, meaning that we have this element. We put this field file name with path using our file name, which is the first line, and then we go and read and apply read file data from the get parameters from file, which is exactly this method here that I have illustrated a couple of minutes ago. So, first step is skip the header. How can I skip the header? In Java 8, I just use this one strings here. And that contains mostly a lot of things. So let's copy in a different file, new. Let's put a different way here. Control new annotation example, no other. Okay. Okay, so we just use here just to separate the file here without any side effect on the rest. So what is data? What is data? Data is an object of type get parameters from file. Okay. Text is an array list. Data.text is an array list of string. A sequence of strings. Now this new command here, stream. What does it mean, stream? Stream means that I am creating a sequence of the data read, and a stream is a sequence of elements which can be of different complexity. Maybe they can be a collection, they can be array list, they can be linked list, they can be hash maps, they can be an array list of an object that we create, whatever we do. I say a sequence, but not necessarily in the sequence there is an order. The order can be given in different ways. Anyway, it depends then on the method that I have to act on the string. I open this string and I actually opening the streams means also that we are creating a stream object. And then we can do various operations on the string object. One operation, names of this operation are map, filter, sum, print, and we will see some of them. These operations can be subdivided mostly in 3 classes of operations. Terminal operation that do something, like, for instance, they sum the number of the strings in the streams and produce the total, which is subsequently put on the output. These do things and doesn't return anything. And the stream is said to be consumed. And I cannot utilize anymore the stream. I have operations that build another streams. So I start with a stream and I obtain streams and I can do other operations on the streams. And finally, I have the collector operation in which I collect what I have done, and maybe I built a new class, a new array list, a new collection. So let's see what we are doing here. So we create a stream, a flux of data, and we filter the data. Filter get as inputs a Boolean, meaning an operation with return a Boolean. If the Boolean is 1, true, the object in the stream is retained, otherwise is not retained. As you can see, filter is an operation that can be done in parallel, because usually if I have, for each element, I build a Boolean. Actually, it could not be a Boolean. It cannot be in parallel if creating this Boolean requires operation that involves more than one element in the strings. Then I have to do something more complex, and there are ways to do it. But here, what I want to do is I have a certain string. If this string starts with, I want to select the string that starts with the hashtag. So I know that the class string has a method which starts with, and return a Boolean 1 if true, if the string starts with that symbol. So what I am saying here, I say, okay, takes the string S, tell me if it starts with the hashtag, and if yes, return true. Actually, here I want to filter things that do not start with the hashtag. So what I say, okay, if it is true, I don't want this. In Java, as in many C type of language, if I want to change, to flip the Boolean, I have to put the bang sign. This is the bang sign. Say, so if the string starts with the hashtag, please no, this is not what I want. Actually, you see here there is an additional things that say s minus greater than, which is an arrow actually. This denotes a lambda, a concise way to describe a function. Say, each element in the stream, S, which is, we know, is a string, on each element of S, do this operation, transform S in S start with, in this case, hashtag. So for each element, this says, I am going to see if it starts with hashtag, there is a bang in front, I put false if it starts with a hashtag. So the main result here is that if we say filter these things, and if my string doesn't start with a hashtag, is past the filter, is selected, is not filtered out, but is filtering in, is kept. So recapitulating, data text is my text transformed to a string. And here I filter only those lines that do not start with the hashtag. Keeping away the bang, I will select just the line that start with the hashtag. Now here we have one terminal operation, which is for each. Actually, it's terminal because it is used here with the system out println. Says for each element of the stream, my terminal operation here is take the system out, the println method in the system out class. And please note also this notation here. Also, this notation is a new introduction of Java 8, which is for indicating a method of a class with the two semicolons that separate the class from the method that I want to select. So let's go. As you see that this structure here is extremely concise, extremely terse, but in a sense beautiful to see. I wrote in the first lesson that I gave that the code must be short. And this is quite a short code for doing such a complex operation. So once I have understood what it does, and I am sure that you will understand very easy in few minutes. It becomes very convenient to use it. Now the second thing is now we have skipped the header because I skipped the header here, but I I skipped it here either just with the scope to print the whatever is skipped. I didn't do really any interesting things here. So next thing is I have to do the same operation, but instead of applying this for each here, I have to store what I have done in something. Now you see here, okay, so this something is an array list of string. So I declare here an array list of strings, which I call filtered data. I can apply exactly the same thing that I just explained. Take the data, text, open streams, filter the data that the line that do not start with the hashtag. Then this operation here returns to me a string, sorry. And on this stream I have to collect again the things. So I use the method collect, which is I can apply to a string. Let's put it here to separate much better example here. Now we cancel this one and put this one. Say collect. Take a collector object. Or in practice, I have collectors. Collectors objects acts on the stream, and I have methods to transform the stream into other things. In particular, there is a method to collection. These collectors method take a stream thing and transform to a collection. Which type of collection? An array list. And we have to learn a little bit these things. The array list has to be created. Someone has to take care to create the array list, and the way to tell to the to create the new array list is to put .new here. More or less, we have to learn these things. When we have to create a collection inside a collector to collection, you have to use this command written in this way. So, summarizing, in these two lines, what I do is read the stuff, filter out the comments, and takes just a line that just the lines that are not comments. If you look at the file, simple text, what does it mean? It means that it takes away these first 4 lines, and also it takes away also this one. So the result is the remaining the 3, and then the pure data in a sense. Where the first data, I have to know in advance, is the number of lines and then the other data are the real data. You know, here I put the obtain numerical, not numerical yet, but to be numerical data in filtered data. Still in filtered data, I told you that I have the three and then the real data. So because the first data is is not useful for the operation that I have to do. I have also to skip the first data. How to skip the first data? I have also another command that acts on streams, which is skip. I take as input a number, and the number is the number of elements that I have to skip. Here I put 1, so I skip 1 element. If I put 0, skip 0 element. If I put 3, it skips 3 element. And then for each, in this case, I don't do anything particular because I have already my data here. I just print. I want just to check that what I have done return me just the pure data that I need. This way to put in sequence the command is called piping usually. Who is used to have some knowledge of Bash or some Unix type of commands know that what piping is putting line many commands in one in sequence of the other, and this is what we do with the dot here when we connect various commands. Okay. The other thing is here I have an alternative, which is I just do the two operations that I have made above. Here I do in sequence, which means I get the data object, I get its text, I do a stream with the text, I filter all the stuff which starts with the hashtag. I skip the first element of what it is remained. Yeah, I have to keep in mind what I am doing, obviously. In this point where I do these things, I have to have clear, which is quite an exercise sometimes to know where I am in each point here. So here I have the text without comments. I skip the first line of the remaining text. Then I collect to what is remaining in an array list. So this new array list contains 3 elements, each one which is the line. I call this filtered data 2. On this filtered data 2, again, I open a stream because there is no any more streams here. I already consumed, and for each, I print the elements. So what I am doing here now is to do the 3, 4, and 5 things, which is 3, 4, and 5 is, remember, is tokenize the data, split the lines into its components, meaning into its words, transform the string into numbers, and then add them to an array list. Using this way, I can do again in a single operation. I say filter data 2, I transform in a string, and for each what I do, I take each value, which is the whole string, and therefore I apply a method which is stream to sum. What is this stream to sum? This is what we do here. String to sum. In order to get very clear the command here, I could have put all the method inside here in some way. but it was in that case the code was cluttered. So I did string to sum. I think that take one string S, split the strings, transform to double, and sum the things. I need the two methods that I have here. So I have a string to sum. I take a string trial. So here I create an array list of doubles. Okay, I have a warning here. Okay. And the list of string. String is another type of collection. Okay, no, is an array list at the end. But you see here what I did in particular things that should be useful to remind. What I am creating is an array list. And you see when after the new command, I am creating an array list of string. But I define it to its super type, which is list. This is a way to do it because it reminds a particular statement, which is a rule, which sounds like program to interfaces, not to classes, concrete classes. List is the interface of to which array list implements. Also, other collection implements list like linked list, like hash maps, like in this moment I don't remember what, but like map. All of them implement list. So what does this new array list? This new array list actually, which is an array list of strings, take the string I have in input, and I have this command arrays as list, which acts on array, and as argument trial, which is a string, method split that you already saw other time, argument, the regular expression, any sequence of empty spaces. So what I am saying is trial is a string. I apply the method split, which is a method which acts on a string. You split the strings into components, separating the elements with the blank spaces. As a result, here I have a vector of strings. I want to transform a vector of strings, an array, actually, as in the Java language, the array to a list. And there is this further method, which is as list, that act on arrays and transform arrays in lists. We already used it before for transforming a vector of doubles into an array list of strings and then printing it. So we take a list of strings here, and when I invoke this one, which is a constructor of array list of string, if I give this constructor with an argument, which is a list, the list is created with the space allocated for the input list. So I do whatever I have to do. Now, the other thing is here I have read each line essentially in my at the end of the thing. Each string into a array list of strings. Now I have to transform each element of the strings into a double. What I am doing it here, I am using the same method that we are using before. Essentially, I create a vector of doubles called need. So I take the array list of string stList, open a stream, other intermediate method allowed defined on streams, which is map to double. There are a lot of generic operations on streams, but there are also some specialized operations. One of these specialized operations is this map to double, which was created appropriately for transforming strings and things to a double, or there is a map to integer at the same time, and to avoid particular overheads in calculations. As you see, in fact, in this line, I am returning an array of doubles, a vector of doubles. But the primitive double, not the class double, which has the capital D. This is because map to double does these things. Acting on the primitive double instead of the class double has a lot of advantages from the point of view of execution, because if I have a class of doubles, I have some advantages, but each time I do an operation, I have to unbox the real number from the class. I have to open the envelope, take the number from the envelope, and then do the operation. Here instead, I open once forever the envelopes and create a vector, an array of doubles. And what I map to, what means maps to doubles? Means I take for each element is map to double is in a sense for each element of this stream, do this operation. But then transform into a double, primitive double. So I take each term S, and to each term I apply double pass double, which is an operation that we already seen before. We transform each string S into a double. Then there is a particular method that acts on this map to double, which is actually map to double creates a stream of doubles, of primitive doubles, and instead of using collectors, etc., we use this specialized method to transform to an array. How to know that? You have to study what collection does. There is one book which I share with you about collections, and I will indicate 3 chapters that has to do with streams. You can read this chapter pretty easily to understand all of this operation, and then the rest comes from exercising. Finally, I do the stream. Here I create an array of doubles just to show you that then I have a normal double, and if I want to do the sum, for instance, I can do a for cycle as we did before in cases before, and sum the elements of the neat thing. But I didn't do actually here, because what I do was just calculate directly the sum with the same operation that I did before. Instead of putting two arrays here, there is a class which is sum, that just take the stream of doubles and sum them. Don't need to pass through an intermediate operation. So this is what I really do, and actually here I return sum. So essentially you see a warning here because I am not using this neat value. I just created to show to you what, how it's possible to save the data into an array. So what we do here is we apply string to sum and obtain what we do. We also use somewhere text to double, which I don't remember now where. Text to double is simply a part of all the things that I do here, and just return a string of doubles. Here I do in a traditional way. If you analyze the code, I could have used just this command here, inside here. So this line here just substitute what it happens here. So I think that for the moment we can stop here, and we didn't do the final operations, but we will see the final operation maybe tomorrow in main D and main E. Actually, in main D, we see the final 6, 7, 8 operation, which is printing the data and writing the data, using also using this type of approach with streams and lambdas. And in main E, finally, I separate into sub methods all the operation in the main to abstract some of the operations. As you see, they use the lambdas and the stream allow to Java 8 will allow us to get the main in the main organized in a little different way from the main B1 that we saw before. Main C. Okay. Main B1. And that's all I think for today.